this.
Okay.
So the shoe is down, but other than that, I don't
Okay.
So we're going to talk about continuity. Three things you have to be continuous. Two-sided limit exists, so that means like the roads come together, they meet, the limit would happen because they'd be the same from both sides. The point exists, so like there's a dot, and the limit and the point are in the same spot. I'm going to refer to these as the roads meet, the bridge exists, and then the bridge is where the roads meet. Did you guys do continuity in pre-con?
Yes.
Okay.
It's like the very end.
Yeah. Love it. Good. Alright, so I want to build a bridge to get over this river. I've got a river and I can't get across it. So I need to build roads to get to the river and then a bridge to get over the river. So I call it Mr. Merch. Merch Construction Company. And it's going to be apparent pretty soon. And he builds a road that goes over there. He builds a road that goes over there. And then he just like forgets and walks away, and that's the end of his project. Is the graph continuous at that point?
No.
Okay, so this would not be continuous. What qualifications is he not meeting? Limit doesn't exist. Point doesn't exist. And this is what's called a jump discontinuity. So I'm not getting over that river. On either side, I can walk up to the river and look at it. But then I can't even see the road on the other side. Alright, then I call Diaz. Diaz is like, Merch, you're an idiot. You didn't even build a bridge. So Diaz builds a road, builds another road. I think he's like drunk and comes in the next day and builds a bridge, and they're all three totally different spots. So Diaz fixed one issue, but he didn't fix. So what issue did he fix?
The point exists.
He built a bridge. The point does exist, but it's in like a completely horrible spot. So it's still true that the limit doesn't exist. That is another jump discontinuity. At the end, I'll like define what that is. Discontinuity. I was about to say discontinuity. I just can't spell it. I have to like go retrace my steps. Discontinuity. Right. All right. Then we call Gina. Gina's like, you guys are just dumbasses. If you're going to build a road, put the frickin' bridge at the end of the road. But then she goes home, forgets where she is, the next day builds a road, different spot.
Sounds right.
So, she's getting closer, but what's still a problem? Limit doesn't exist. So that's a jump. Let's see if I can do this. Discontinuity.
So are these people in Scotland?
Yeah.
Okay.
You want to go next?
I'm sorry.
Discontinuity. This is what seniority says.
Alright, then we call David. David finally makes the roads meet. I'm getting pumped up, I'm watching him, like, okay, cool, he's making the roads come together, and then he builds a bridge, like, wait a minute. So what's his problem?
I don't
I mean, not like what's his problem, but in this scenario, what's his problem?
The limit doesn't
The limit does exist. The point does exist, but they're not in the same spot. So the limit does not equal the point. This is called a removable discontinuity. Because if I just moved the bridge to a better location, would it fix the problem? That's a removable discontinuity. Your limit exists, so if you could just move that bridge where it's supposed to go, you could fix the problem. And then we'll go through like how to do that. Okay. Well, yeah, you guys finally caught me. And we got two roads to meet, we got a point, and they're all in the same spot. So that's continuous. Three types of discontinuities. One is a jump. So you got the roads don't meet, so something like that. Like the left-hand side and the right-hand side are different. You've got a removable. Which says the limit exists. The point doesn't match. So that's like one of those. That was David's. And then I didn't draw this one because I didn't really know how to make it work with like the river story, but there's an essential, which is just a vertical asymptote.
Someone tries to build a bridge and build it into the river and it floats down the river.
Well, you can't touch the river if it's asymptote. You just keep getting closer and closer to the river.
Driving your bridge just goes straight up.
Right.
I just made it
All the way up to
to
it's a ramp.
So a vertical asymptote would be an essential discontinuity. So, there's two ways the question would be asked. It would either be, here's a graph, tell me where it's not continuous, and then identify which type, or here's a graph, tell me where it is continuous. It could be either way. So, let's draw a graph. So list all discontinuities and tell what type. You guys probably need a second to draw that. They told me the air conditioning was on, but I was sweating. Sitting down. Shin told me like an hour ago it's on now, but maybe it's just really, really slow.
Or should turn on really, really low.
Yeah. You guys still drawing?
Yes.
You this thing then if you'd like, or you can wait for me if you'd like. Is that 14 we get out? 60. That's 20. So here I'm looking for the problems. Like, where is there a situation where I wouldn't get over the river? So everything's fine until I get to here. This is a discontinuity, right? What type?
Jump.
So x equals -2 is a jump. Where's the next one as I read left to right?
0, 0.
What kind is that? Movable. As I keep going,
X equals 2.
x equals 2 is essential. What'd you call it? That's another way to, yeah. Because you go into infinity, it's another phrasing. The other way they would ask this is list where the function is continuous. So you're breaking it into parts based on where it is okay. So you're kind of, you identify where it's not okay and you like build intervals around those. So there's a discontinuity -2, right? But it's fine all the way up until that. So it's fine from -infinity up to -2. Now from this direction, do we want to include -2? We don't because it's an open circle. When I go to the next section, will I include the -2? Or will? So it's continuous from -infinity to -2.
What do you use brackets?
That when I include it.
I can't remember. Can you move up the paper, please?
Yeah, so it's,
This chair.
I'm trying to show like both of those. Hold on.
I thought you were okay.
Not serious right now. Okay. So parentheses means you don't include it. Bracket means you do. I put a parenthesis by -infinity because you can't ever include -infinity. Like if you said, well, I'm going to use -infinity, I can be like, okay, well, I'm going to do -infinity -1. And then you can be like, fine, jackass, I'll do -infinity -10. And then we can just keep going forever. So there's no way you can put a boundary on that. So that's why it's parenthesis. This is a parenthesis because from that side it's an open circle. If I go to the next section, well, now the -2 is included, right? Now it's a closed circle. That's when you put the bracket. -2 up to 0, and am I including 0? So bracket or parenthesis for 0? Parenthesis. Because at 0, that's an open circle. And the closed dot's down there, but we're not continuous because they're not in the same spot. What's my next one? 0 to what? 0 to 2, I'm not including either of those because that's an open circle, and I'll never touch the 2, right? So it's an asymptote. And then, what's the last one? 2 to infinity. Yeah.
I learned to put the U's for union in between those. Is that a thing? Or is that
You can. Comma's fine too.
Oh, how
Like you did this, union this.
Yeah.
Yeah, that's fine. Comma's good too, either way. Questions on that right there? I'm going to ask some other questions too. So I'm going to ask a question, wait, like don't say anything for like 5 seconds, then I'll say okay, answer. Let everybody shout out whatever they think. What's the limit as x goes to -infinity? Ah! You didn't follow the rules. Who was that? Walmer? Wait 5 seconds. What's the limit as x goes to -infinity? Okay, what is it?
Infinity.
Positive infinity. So as x is going all the way this way, what's the y value doing? It's going up forever, right? What's the limit as x approaches -2?